We are discussing a very simple concept of moment of inertia in this video called the perpendicular axis theorem or perpendicular axis theorem. We discussed the parallel axis theorem in the previous video here. You can have a look at the moment of inertia first video just to recapitulate your memory, and we discussed the parallel axis theorem in this video. Now we are discussing the perpendicular axis theorem. So the perpendicular axis theorem. It's very simple. We discussed the moment of inertia about an axis. Say for example, x-axis is summation of dA y square, where you have an area, and if you want to find the moment of inertia of that area about, say, this axis, let's call this x-axis, and then you divide this into too many small areas, and you find the area of each of these portions, and what you have is Ixx, that is the moment of inertia about the x-axis, is summation of these small areas into the square of the distance to the area. For example, this is the center of gravity of the small area and this distance is y, and you find the y square for each of this area and find this product. Now you know the integral of summation dA or summation of dA. When you integrate this entire area, what you get is the total area of that shape. So you have ay square, that is your moment of inertia about an axis. Say because it's y square because it's about x-axis, and similarly you have I about y-axis is equal to a x squared. Now for the perpendicular axis theorem, what we are saying is, if you know the moment of inertia of an area about two axes which is mutually perpendicular to each other, then the moment of inertia of the same area about a third axis which is perpendicular to both these axes will be sum of the moment of inertia of the area about the other two axes. If it's I know you may be slightly confused, so let me write it. If you know Ixx and Iyy here, then Izz is equal to summation Ixx plus Iyy. Now it's clear, I think, I hope. Because you know the moment of inertia about y-axis, you know the moment of inertia about x-axis. Now these two axes are perpendicular to each other. If you know these two values, then you can find the moment of inertia about the third axis. The condition is that axis should be mutually perpendicular to both these axes. Then this will be your moment of inertia. Let's see how we can prove it. I've drawn a picture here. You have your x and y axis, and you've got an area here. So you have Ixx equal to summation dA y square and Iyy equal to summation dA x square. Now if you look at this figure, you can see this line here is the distance between the centroid of this area to the z-axis, and again, as you can see, this is a right triangle, and where you have one distance x and the other y. So let's call this z. So from this figure you have z equal to square root of x squared plus y squared. That's just using the conditions or using the equations of the right triangle. You have your perpendicular and your base and your hypotenuse. So your hypotenuse is equal to square root of perpendicular square plus the base square. Now what we said earlier on is Izz equal to ixx plus iyy. Now if you follow these two conditions, you can write izz equal to summation dA z square. Now you know z square, z is root of x squared plus y squared, so z square is x squared plus y squared. Let's substitute ixx and iyy here. So you have ixx summation dA y squared plus summation dA x squared, where you have summation dA as a constant term, so you can write summation dA y squared plus x squared. Now y squared plus x squared is z squared, and therefore you have your condition here, which means izz equal to ixx plus iyy.